everyone, welcome back to my YouTube channel. I hope you all are doing well. So today in this lecture we will discuss remaining questions of exercise 7.3. So in exercise 7.3 our sixth question is find n if n minus 1 p3 ratio and p4 is equal to 1 ratio 9. So here we have to find out the value of n. So let's get started. So n minus 1 p3 upon n p4 which is equal to 1 upon 9. Right? We can write like this. Right? Now we know the formula of NPR which is equal to n factorial n minus r factorial. So here n is equal to n minus 1 and r is equal to 3. Right? So n minus 1 factorial upon n minus 1 minus 3 factorial. Right? And in denominator n factorial n minus 4 factorial which is equal to 1 upon 9. Right? So in the next step, here 1 upon 9. Right? So in next step, n minus 1 factorial upon n minus 1 minus 3 which is equal to minus 4 factorial into n minus 4 factorial and factorial which is equal to 1 upon 9. So cancel each other. N minus 1 factorial we can write n factorial like n minus 1 factorial which is equal to 1 upon 9. So n minus 1 factorial cancel each other. So 1 upon n is equal to 1 upon 9. So n is equal to 9. Right? It's a very easy question, right? We can write ratio like this, right? N minus 1 p3 upon n p4 which is equal to 1 ratio 9 we can write like this 1 upon 9. Now put the value of NPR. We know the formula NPR n factorial n minus r factorial, right? And then solve this question and we get the value of n which is equal to 9, right? So this is our sixth question. So our next question is, that is question number 7th. First part is find the value of r if 5pr is equal to 2 into 6pr minus 1. So again this is a very easy question. Again we will put the value. We know the formula of NPR. We put the value of n and r. Right? So 5 factorial 5 minus r factorial. Right? Because we know NPR is equal to n factorial n minus r factorial. Right? In the next step, 2 into 6 factorial 6 minus r minus 1 factorial. Right? Again 5 factorial 5 minus r factorial which is equal to 2 into 6 factorial 6 minus r minus minus plus 1 factorial. Right? So 5 factorial 5 minus r factorial which is equal to 2 into 6 factorial 6 plus 7 minus r factorial. Right? So in the next step 5 factorial 5 minus r factorial which is equal to 2 into 6 factorial. We can write 6 factorial like this. 6 factorial we can write 6 factorial like 6 into 5 factorial. Similarly 7 minus r factorial 6 minus r factorial and 5 minus r factorial. Right? Because we know we can write n factorial n minus 1 n minus 2. Right? So you can see here 5 factorial upon 5 minus r factorial and 5 factorial 5 minus r factorial, they are cancelled out each other, right? So we got 1 in the left side we left 1 which is equal to 2 into that is 12 upon 7 minus r 6 minus r. Right? Cross multiply. So 7 minus r 6 minus r is equal to 12. And now just open the bracket. 42 minus 6r minus plus r square, that is 12. So r square minus 6r plus 42 minus 12 is equal to 0. Right? So r square is equal to minus 6r plus 30 is equal to 0. Right? Open the bracket. 7 into 6, 42. 7 minus r, 6 minus r plus r square is equal to 12. So r square, that is minus 13r. So 42 minus 12, that is 30 is equal to 0. Now we will make a factors. So 10 into 3, 13, and minus 10 minus 3 is 13. So r square minus 10r minus 3r plus 30 is equal to 0. 10 into 3, 30, and minus 10 minus 3 minus 13. So r minus 10. So r minus 10 minus 3. So r equal to r minus 3 and r minus 10 equal to 0. They are two factors. Therefore, r equal to 3 and r equal to 10. So we know that the value of r can never be greater than n. So n is always greater than equal to r. N is equal to r and n always greater than equal to r. So here we can see here n is equal to 5. Right? So we can't take r equal to 10. Right? So r equal to 10 is neglect because r can't be greater than n. So therefore r equal to 3. So this is the value of r. Right? So 7th question, second part is find the value of r if 5pr is equal to 6pr minus 1. So similarly like 5 factorial, 5 minus r factorial, and which is equal to 6 factorial, 6 minus r minus 1 factorial, right? And the next step 5 factorial, 5 minus r factorial, 6 factorial, just open the bracket, 6 minus r minus plus 1 factorial, right? So in the next step 5 factorial, 5 minus r factorial, 6 factorial, 6 plus 1 7 minus r factorial, right? In the next step 5 factorial, 5 minus r factorial, and we can write 6 factorial, 6 into 5 factorial, and 7 minus r, 6 minus r, and 5 minus r, right? We can write 7 minus r factorial, which is equal to 7 minus r, 6 minus r, 5 minus r, right? So in the next, you can see here, they are cancel out each other. Then we got in the left side 1, which is equal to 6 upon 7 minus r, 6 minus r. So 7 minus r, 6 minus r, which is equal to 6. Now just open the brackets. 42 minus 6r. 42 minus 7r minus 6r minus plus r square is equal to 6. So r square is equal to minus 13r plus 42 minus 6. Right? So r square minus 13r. So 42 minus 6. That is 36 is equal to 0. So 9 into 4, that is 36, and minus 9 minus 4 is equal to minus 13, right? So now r square, so 9r minus 4i. 9 into minus 4, that is plus 36, and minus 9r minus 4r, that is minus 30r, right? Plus 36 is equal to 0. So r minus 9 and minus 4, so r minus 4, r minus 9 is equal to 0. So two factors are r minus 4, r minus 9 is equal to 0. So we got r equal to 4 and r equal to 9. Again you can see here, we can take r equal to 4, r equal to 9 can't be possible, so it will neglect because r can't be greater than n, right? R can be equal to n, but r cannot be equal to n. So this is 7th question, second part, right? So our next question is, how many words with or without meaning can be formed using the word equation using each letter exactly once, right? So here we can see here, there are, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 letters. 8, you can write 8 different letters. Each letter are different. So 8 letters, there are 8 different 8 letters. So here there are 8 different letters and each letter is different, right? Now we have to find the required permutation, which is equal to number of arrangement of 8 different letters taking all at a time, right? So by the use of 8 letters, we will form a 8 letter word, which means number of arrangement of 8 different letters taking all at a time, means taking 8 at a time, which is equal to 8p8, which is equal to 8 factorial, or 8 factorial we can write like this: 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. You can multiply all these and you will get answer 40,320. So this question is very easy question, right? We have already practiced these types of question in previous lectures, right? So our next question is, how many words with or without meaning can be made from the word Monday, assuming that no letter is repeated, and first condition is if 4 letters are used at a time, right? So in Monday, how many letters are there? 1, 2, 3, 4, 5, 6, right? So here there are 6 different letters. No letter is repeated here, right? You can see here that all letters are different. So solution: total number of different, all letters are different, total number of different letters, which is equal to 6. 1, 2, 3, 4, 5, 6. So our first condition is 4 letters are used at a time. So permutation of, we have to find the arrangement or permutation of 4 letters are used at a time. So you can write, so number of permutation of number of permutation of how many letters? Total number of permutation of 6 letter taking 4 at a time. So total number of letters 6 and taking 4 at a time. So 6p4. So 6p4 is equal to 6 factorial. 6 minus 4 factorial. Right. Next step 6 minus 4, that is 2 factorial. So 6 into 5 into 4 into 3 into 2 factorial. Right. So 6 5 the 30. The answer is 360. So 360 word can be formed by the use of 6 letter taking 4 at a time. Right? So this is our first condition. So second condition is all letter are used at a time. Right? So in the previous condition, all 4 letter used at a time, and here all letter used at a time. So permutation of the required, you can write the required arrangement equal to the permutation of 6 different letter. We have total 6 different letter. These 6 different letters taking all at a time. So which is equal to 6p, 6, that is equal to 6 factorial. So 6 into 5 into 4 into 3 into 2 into 1. 30, 12 into 2, 30 into 0, 6 to the 12, 720. So 720 words we can formed by the use of 4 letter, by the use of 6 letter, these 6 letter taking all at a time. Right? So this is our second condition. So in this question, our third condition is all letters are used, what first letter is vowel. Right? So in Monday, how many vowels are there? We have 2 vowels. Right? So we have 2 vowels. Those are O and A. So we will form a 6 letter word. All letters are used. Right? 1, 2, 3, 4, 5, 6. Right? What condition is first letter is vowel. So first letter here. So here in first position, first letter should be vowel. So in first position, we can see here that we have 2 vowels, which means we have 2 possibilities. Either O will come, or A will come. Right? So we can write in first position we have 2 possibilities. Right? So 2 possibilities, therefore total possible arrangement, you can write these words in your own way. Right? So total possible arrangement in first position equal to 2. Right? So now how many letters are left? 5 letters are left. So out of 6 letters, 1 letter is first position. Now the remaining letters, now we have to find the, we can say, permutation or arrangement of 5 letters. Right? One is already filled, either or A. We have total 6 letters. Out of 6 letters, one is already filled. Right? So remaining 5 letters are left. So here 5 letters are left. Now so number of permutation of remaining letter, we can write 5, total 5. Now and 5 vacant position to be filled. So 5p5, that is 5 factorial. 5 into 4 into 3 into 2 into 1, 20, 120. Right? So in the next step, you can write therefore the required arrangement when first letter is, you can write the required arrangement when first letter is vowel. So 120 into 2, that is 240 words can be formed when first letter is start with vowel. Right? I think this is also a very easy question. These types of question we have already discussed in previous lectures. We have done lots of examples like this. So our next question is, in how many of the distinct permutation of this given letter, right, and then do the 4 eyes not come together, right? So in this question, first we will find the total number of arrangement, right? So in the next step, we will find out all eyes come together, right? But we have to calculate 4 eyes not come together. So most of the question we discussed, all eyes come together, all vowels come together, but in this question we have to find out 4 eyes not come together. So we have to subtract 4 eyes come together from the total number of arrangement. This will be the process of this question. So let's get started. First, here there are how many total number of letters in this word? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 12 letters, out of which I occur 1, 2, 3, 4 times, right? Similarly, S occur 4 times and P occur 2 times, and you can write rest all letters are different, right? So here total word formed by the letter of the given word. So first we will find out total number of word, or we can say total number of arrangement can be formed from these given 11 letters. So 11 factorial, and in denominator repeated element can be written here. So I comes in 4 times, 4 factorial into 4 factorial into 2 factorial, right? So we will solve it. 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial. and in denominator 4 factorial. 4 into 3 into 2 into 1, and we can write 2 factorial, 2 into 1, 4, 4 cut each other. Then 4 to the 8, right? 2, 5 the 10, 3, 3 the 9. So after all multiplications, you will get an answer that is 34650. So 34,650 words can be formed from the given 11 letter. So here there are total number of arrangement, right? So in the next step, this answer keep in mind, okay? Do the 4 i's not come together? So first we will find all I come together. Right? So first we can write out of, how many letters are there? Out of 11 letters, 4 i's come together. We left 11 minus 4, that is 7 letter. What? We treat 4 letter as a single letter. Then we get 7 plus 1, 8. Total letter, that is 8. Out of which, no, we will ignore the I. 4 I come together, right? So out of which 4 S comes 4 times and P comes 2 times, right? So all I come together. So for example, we have 11 letters. We have 11 letters. Out of 11 letter, condition is 4 i's come together, right? So 11 minus 4, that is 7. So here 7 letters are there, right? But take this 4 letter as a single letter, right? So 7 plus 1, 8. Now, right? Now we have total 8 letter. So 8 factorial upon 4 factorial into 2 factorials, right? Now we will, here we will, in denominator we will not write again 4 factorial, because 4 I come together and we treat like a single word. So 4 factorial is 4 S come together and 2 factorial is 2 P comes together, right? So 8 into 7 into 6 into 5 into 4 factorial, 4 factorial 2 into 1. 2 4 the 8, and you will get answer, that is 840. 40 are those letters when all i's or all 4 i's come together, right? But 840, right? But we want to find out 4 i's do not come together. We have to find out the permutation of all 4 I do not come together. So we have to subtract total arrangement minus vowels I 4 I's come together. So total arrangement are 34,650 minus 4 i's come together, that is 840. Then you will get an answer, that is 33,810. So 33 arrangement are possible when all I do not come together. Right? So, this is our 10th question. So, our 11th question, which is our last question of in this exercise, is in how many ways can the letter of the word permutation be arranged? First condition is word start with P and end with S. Right? So, first, how many total letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, there are 12 letters, right? Out of which you can see here, out of which T occur 2 times and rest all letters are different. Right? Now, first condition is word start with P and end with S. So, out of 12 letters, P and S are fixed. P at first position, S at end position. Right? Therefore, so remaining 10 letters left. So, required permutation of 10 letters which start with P and end with S. So, 10 factorial upon repeated letters, T comes in 2 times, therefore 2 factorial. So, 10 into 9 into 8 into 7 into 6 into 5 into 4 into 2 factorial upon 2 factorial, they are cancel out each other. Then after all multiplication, we will get a answer. So I hope you understand this first condition. In first condition, P and S positions are fixed, right? We don't have to arrange these positions. We don't need to arrange these positions, right? Because they both are fixed, right? So out of 12, 2 positions are fixed. So we have left 10 letters, right? Now we have to arrange these 10 letters. We have to find out the permutations of 10 letters. So 10 factorial upon 2 factorial. T comes in 2 times. That's why we write it here, right? So this is our first condition. So second condition is vowels are occur together, right? So here how many vowels are there? So total number of vowels E, right? E, U, A, O. E, U, A, I, O. So here 1, 2, 3, 4, 5. 5 vowels are there, right? So we have to find out the vowels are all together. So here out of 12 letters, right, now we have total 12 letters. Out of 12 letters, 5 vowels E, U, A, I, O, right, always come together, right? So always come together. So we treat these vowel like a single letter. Right? This is our single letter. Right? So out of 12, 5 are vowels which are fixed. So 12 minus 5, 7. So here 7 letter will be filled. Right? And vowels we treat like a single letter. So 7 plus 1, 8 letter. So now we have to arrange the 8 letter. So permutation of 8 of remaining 8 letter. So 8 factorial upon t comes in 2 times. 2 factorial. So 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial. And cancel out each other. You will get answer 20,160. So vowels are all together. These types of condition we have already discussed. So that's why we did it directly. Right? We have 12 letters. Out of 12 letters, 5 letters are fixed. Means 5 letters are occur together. Right? So we take it as a single letter. So remaining 7 letters, 12 minus 5, 7. And we consider these vowels like a single letter. Then 7 plus 8 means we have total 8 letters. Then we have to arrange these 8 letters. So the permutation of remaining 8 letters, 8 factorial upon t comes in 2 times 2 factorial. So 20160. Now you can see here these vowels can be arranged themselves. Right? We know you can write here these vowels can be arranged themselves. Right? Permutation of vowels. So there are 5 here. There are 5 ways because E, U, A, I. They will also arrange. How? Right? O first come O, U, A, I, O. Yeah, U, E, A, I, O. Right? So here 5 factorial. Right? 5 into 4 into 3 into 2 into 1. That is 120. Therefore, the total number of arrangement when all vowels occur together, then we have to multiply 20160 into 120. Then we will get a answer. So this is our second condition. All vowels are all together. Right? So the last condition is there are always 4 letters between P and S. Right? In this condition, we have to find out those words where 4 letters between P and S. So here, total number of 12 letters. We have 12 letters. Total letters are 12. T comes in 2 times. Right? So 4 letters between P and S. So first make a 12 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are always 4 letters between P and S. If we write P at a first position 1, 2, 3, 4. Here will be the S. Right? So question condition is there are always 4 letters between P and S. If I shift P in this side, so S will also shift. Right? Then if P comes in this position and S comes in this position, then the in between 4 letters will be left. Right? After that, here P. If I P shift here, then S will also shift here. Right? Again, if P is here, S is here. How many letters are left between P and 1, 2, 3, 4? Right? Again, if I shift P here, so S will shift in this side. Again, 4 letters left between P and S. Right? Again, P shift here, and sorry, this is S, and S shift here. Again, P shift here and S shift here. Right? Again, if I shift P from here to there, the S will definitely shift in this position. So here, how many ways we shift the P? 1, 2, 3, 4, 5, 6, 7. Total shifting of, we can say shifting of P, which is 7 times we have shift the P. Right? Question is not saying that always 4 letter between P and S. Right? It can be between S and P. Right? Here S and here P. So question is saying that not always start with P. It can be start with S, but 4 letter between S and P. There should be 4 letter between P and S, or we can say S and P. So here the shifting, total shifting of S will be again 7. So total arrangement of, that is 7 plus 7, that is 14. Total possibilities of shifting of P and S. Right? So in the next condition, now we will find out total arrangement. Here we can say total arrangement. Here we can say total arrangement when 4 letter between P and S. You can write here like this. Right? Now P and X are between P and S. P and S are fixed position. So out of 12, 2 letters are fixed, which we don't need to arrange them. Right? So S and P are fixed. Here we can say P and fixed are 6. We can say P and S are fixed. So out of 12, we have to arrange the 10 letters. 10 factorial again upon T comes in 2 times. Right? And multiply by 14. Then we will get a answer. This answer we will get an answer. So students, that's all today's lecture. So we have discussed all questions of a exercise 7.3. Right? So in the next lecture we will discuss next topic, that is combination. Right? So thank you so much students, and for more videos please like, comment and subscribe my YouTube channel.